Math isn't difficult. Math is fun. I am Neelakantha Bhanu Prakash and I am the fastest human calculator in the world. And we are exploring infinities. Exploring infinities is here in front of you to give you a mathematics learning experience like never before. With expert trainers from around the country, we are here to make you learn math the right way.
Hi friends, this is Joshi Emmanuel and I'm from Exploring Infinities and I'm here to make math more easy for you. You know, I understand that math is difficult and math is not easy to understand, and especially when it comes to questions which we cannot solve. My God, it eats our brain, right? I know, I can feel you. So that is why we, Exploring Infinities, are here to make your life easy by teaching math in a more fun filled way, by making it practical and approachable, right? So today we will be discussing about progressions. All right. So this topic, progressions, is a very easy topic, very generic, as in you can grasp it very easily. I would say it is, one of the easiest topics in your entire textbook, right? Let's see what the word progression means and, where can we find this in our daily life. Let me ask you something. Have you guys ever attended a school assembly? Did you? You did, right? Yeah. So when you have attended your assembly, do you just go and stand anywhere in the parade ground, or you have your specific class and specific place to start? Yeah, you have your specific row, right? It's not that you go and stand anywhere. You have your class and you have your respective height according to which you stand in a line, right? You're not the person who is standing behind the tallest guy in the class. The tallest guy is at the back, the shortest one is on the front, so that everyone can see, right? You guys know this. You know that there is an order. For example, let's say if this is your school ground, right? Yeah, beginning from class 1 we stand like this is class 1, class 2, class 3, and so on, class 10, right? I'm writing your class 1, 2, 3, and 10. So you stand in an order, right? And also when you stand in a line, you stand so that the immediate shorter one is on your front, the immediate taller one is at the back of yours, right? So this is done generally every time you attend a school prayer, a morning assembly. And why do you think that this is happening? Why do you think that you should follow order like 1, 2, 3, 4? And why is it that you have to stand in a particular place? It's because there is a pattern that is to be followed. In the case of school, it is discipline. It is discipline and order according to which you stand. Right? You cannot say that no. Today I wanna go and stand with class one students. No, you cannot. If you're class 10, you cannot go to class one and stand there. Right? So such kind of observations we find in our daily life has something to do with progressions. All right, let's take another example. This is another practical one. Let's say that your father earns rupees 1,000 when he first joined his job, and when they hired your father, they said that every year we are gonna increase your salary by 500, right? So if 1,000 is your father's salary in 2020, what is your father's salary in 2021? If it is increased by 500, yeah, 1,000 plus 500, it's 1,500, right? Cool. And guess what is his salary in 2022? Yeah, 1,500 is again increased by 500, and that makes it 2,000. Correct. And what in 2023? Yeah, correct. 2500, right? And it goes on increasing as long as he works. So, writing this on a line, it is 1000, 1500, 2000, 2500, and so on, right? This is how the salary is being increased, right? So, here, what are you observing? There is a pattern. The pattern is every value is increased by 500 successively. After every year, your father's salary is increasing by 500, right? So this is a pattern that you're following. And also, in this pattern, there is also terms involved, right? 1000 is a single term, 1500 is a single term, 2000 is a single term. So in a progression, you're observing a pattern, a series, and then there are terms in it. Cool, you got it right. Let's also make it more practical. See, I have a square in my hand, right? Observe this. I have a square, and this square has a shaded region. You see the shaded region, right? Yeah. Guess what is the shaded region proportion of the square? The shaded region is 1/4 of the square, right? Like this is 1/4 of this entire square. Agree? Cool. Now see what happens. The shaded region was 1/4 of square 1. Now we got a square 2, which is bigger. And we see square 1 is 1/4 of the square 2. Square 1 is 1/4 of square 2. Then what is the shaded region? Any guess? Yes, the shaded region is 1/16th of the square 2, because this square 2 can be divided into 16 parts like the shaded region. You get it? Yeah. Now see what happens. We have a bigger square, square 3. See. And what is this shaded region ratio or proportion in the big square, square 3? Guess it, guess it. You can do it. Oh, now don't start taking a paper and doing it right now. You have to do it, but now just make a guess. Yeah, someone has got it. It is 1 by 64. Yeah. See, in this small square, it is 1/4. And in this big square, it is 1 by 16th. And in this entire square, number 3, it is 1 by 64, because this sheet can be made into 64 such small shaded regions. Alright, you get it right? Huh. So this has something to do with progressions. If we note down the values here, what is the value of the shaded region in square 1? 1 by 4. And then what is the value of the shaded region in square 2? Here is the square 2. Yeah, it is 1 by 60 as discussed. And what is its proportion in square 3, this big square? Yeah, it is 1 by 64. Correct? Yeah. Can you find something here? Can you find some progression? Can you find some pattern here? Food for thought. Just keep this in your mind, before which I will tell you what are the kinds of progressions. Okay? There are two kinds of progressions. One is arithmetic progression. Arithmetic, arithmetic progression, and geometric, geometric progression. All right. So we have arithmetic progression, geometric progression. And for you to remember simply, I would say this is addition progression, this is multiplication progression. And I'll explain you why. Okay, don't get confused. Don't think, oh my god, he's already saying a lot of stuff which I'm not getting. No, no, no. I'll keep it slow. You will understand every single point, right? So arithmetic progression has something to do with addition. Geometric progression has something to do with multiplication. And here is the example for geometric progression. Alright, so 1 by 4, 1 by 16, 1 by 64. Do you find a pattern there? Let's see if there is a pattern. 1 by 4 is the first term. What if I multiply the first term with 1 by 4? See, 1 by 4 is the first term and I'm multiplying with 1 by 4 again. And that will give me 1 by 16. And then I am multiplying the second term. The second term is 1 by 16, right? The second term into 1 by 4 again. This gives me 1 by 64. You see, the first term is 1 by 4, the second term is 1 by 16, the third term is 1 by 64. And what did you do? You took the first term, multiplied it with 1 by 4, second term, and multiplied with 1 by 4. Thereby, you're getting a progression there, a series, a pattern with terms specified, right? Such kind of progressions which we obtain through multiplication. It's called geometric progression. Okay, we'll discuss in detail. Right now, our focus is on arithmetic progression. Cool. So yeah, this is arithmetic progression. And now let's delve a bit more deeper. Let's find what is arithmetic progression and what it is going to teach us. Okay, we have just discussed, let's say, any random progression. To keep it very basic and simple, let's take natural numbers. 1, 2, 3, 4, 5, and so on. So this is a progression, right? A progression has two things. One, they have terms. 1 is a term, 2 is a term, 3 is a term, and every following digit is a term, right? And there is a pattern. It's not like 1, 7, 11, 14, 20, 33, 100. It's not like a random series of number. It has a pattern, because if you add 1 to every preceding number, you get the next number. Let's see if that works here. There is 1 here, and I'm adding 1 to the first number, plus 1. 1 plus 1 is 2, and I'm adding 1 again. 2 plus 1 is 3, and I'm adding 1 again. 3 plus 1 is 4, and I'm adding 1 again. 4 plus 1 is 5, and you add and you get a series. So here is the pattern. You're adding 1 to every preceding number, and that's how you're obtaining a progression. So this is actually the definition of arithmetic progression. Okay, to keep it in the form of definition, please try to note it down if you have your notes. The definition of arithmetic progression is this: that an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. What does it say? It says that an arithmetic progression is a list of numbers. So here is the list of numbers in which each term, we know what are terms. Each term is obtained by adding a fixed number. What is the fixed number in this example? 1, right? By adding a fixed number to every preceding number. Like for 2, if you add 1, you get 3. For 3, if you add 1, you get 4. So for every preceding number is the number which is before. Like preceding number of 4 is 3, preceding number of 3 is 2. So for every preceding number, you add a fixed number, you get the series. And at the end it says, except for the first term, because first term can be anything. It can be 5, it can be 10, it can be minus 100. anything. First number can be anything. The progression is actually dependent on the first term, right? So the first term is a given. You don't have to, tear your brain apart to get the first term. It will be given. All right. So first term is not what is your worry about, but if followed by the first term, every term is obtained by adding a fixed number. That is when you observe it as a progression. All right. So I hope you understand this, and let's try working out some progressions. Let's solve some. For example, I'm saying that first term of a progression is, guess a number. Tell me your favorite number. Let's say 4. All right. And I'm giving that fixed number which we add now. Yeah, fixed number is what is it? Let's say 5. 5 makes it simple. Cool. Okay, what is the first term here? So first term is the first number, first fixed number, 4. All right, this is the first term, and the fixed number here, according to the definition, is what we add to get the next number, right? So 4 plus 5, 4 plus 5 is 9. Okay, we got the second term. 9 plus 5 again is 14. We got the third term. Plus 5 again is 19, and so on. So the series is 4, 9, 14, 19, and so on. So here we are finding a series, and we have just made with our own hands, right? It's not somewhere in the textbook where we are finding difficult to understand. It's right in front of us. We have taken a first term as 4, and we have taken a fixed number to add every term, and we got a series here, 4, 9, 14, 19, and it is a progression. It's an arithmetic progression, right? We already made out how to make a progression. So let's see, what are these terms? What are these first term and what are the fixed number called? So the first term is generally represented as A. Alright? The first term is generally represented as A, small a. And then this fixed number is represented as small d. Alright? Small d. And why d? Here it is fixed number. It can be f or n, but why d? D because it is called common difference. What do we call it? Common difference. Alright, from now on we'll be using the word common difference. So this fixed number which we are adding to every preceding number, so this fixed number, this is called the common difference. And we call it a difference because here to obtain we are adding 5, but then we actually get a common difference in a given progression by subtracting. For example, let's take this. Let's take the first two terms. How can we obtain common difference is by subtracting 9 by 4, which gives me 5. And again, let's take these two, 9 and 14. How do we get the common difference here? We have to do 14 minus 9, which gives me 5 again. Alright, we always subtract small number from a bigger number, so we call it common difference. Alright, it has to be a difference only because we subtract small numbers from bigger numbers. Cool. I hope you get this. Okay, let's try and finding a general form in which we denote a arithmetic progression. Let's take the same example. What did we write there? 1, 2, 3, 4, 5, and so on. Right? So what did we just learn? What do we represent the first term as? Yeah, the first term is A. Right. And what is the second term here? A plus 1. Am I correct? Because A here is 1 and adding 1 to A gives me 2. And what is the third term? A plus 2. Okay. And what is the fourth term? A plus 3, right? What is the fifth term? A plus 4. Wow. I can find something here. What is it? What is that? Any guesses? Let me put it this way. What is the common difference in this series? 1, 2, 3, 4, 5, and so on. What is the common difference here? We know how to get common difference. We subtract first term from second term. That is 2 minus 1, which is 1. Alright, so the common difference is 1 and it is denoted by D, right? Okay, now let me try inserting D somewhere in this general form, right? Here I am writing A as it is and I am writing A plus D. Wherever I see 1, I am writing D now, okay? A plus 2 into 1. You get it? 2 into 1 is 1 again. A plus 3 into 1. A plus 4 into 1 and so on. So I'm replacing 1 with D, right? Yeah. Why D? Because it is the common difference and D is 1 here. So first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D, fifth term is A plus 4D and so on. So this is the general form. Okay. Generally, we represent a arithmetic progression by A plus D, A plus 2D, A plus 3D, A plus 4D. And let's see if we can find any geometric progression given some examples. Cool. Now give me some random examples. So I'm saying that this is the general form of an AP, right? I'm saying this is the general form of an AP. Cool. Give me some values. Give me what is A. Any random number. Give me A. Okay, let's take A is 10. A is equal to 10. And give me D. D can be anything. We took 5 earlier. Huh? Let's take number. Okay, keeping it simple, let's take 2. D is equal to 2. Right? A is 10, D is 2. Now let's substitute these values in the general form. What is the general form? I'm writing here again. A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. Alright? And what is A here? 10. And what is D here? 10 plus 2. D is 2. 10 plus 2 into 2. 10 plus 3 into 2. Why am I writing this? I'm just substituting 10 at the place of A, 2 at the place of D. I'm not doing any rocket science here. Alright? 10 plus 4 into 2 and so on. Alright? And that gives me 10. 10 plus 2 is 12. 10 plus 2 twos are 4. 10 plus 4 is 14. 10 plus 3 twos are 6. 10, 3 twos are 6, right? Yeah. 10 plus 6 is 16. And 10 plus 4 twos are 8. 10 plus 8 is 18 and so on. So there you got a arithmetic progression again. And this is also just made by our hands right now. We took A is 10, D is 2 and we substituted the same in a general form. And we got a progression. So here the required AP is 10, 12, 14, 16, 18 and so on. That's it. Alright. So here there can be a question asked. Find the common difference. Randomly they will ask you to find the common difference and you'll be like, oh, I forgot how to find it. No, it's very simple. See, I'm writing the general form again. The general form is A plus D, A plus 2D, A plus 3D, and so on, A plus N minus 1D. Correct me if I'm wrong. Am I wrong here? Array bro, what have you written? You have written a plus n minus 1d, and what is n, and why have you written it in the end? I'm not understanding. Please help me understand. Okay, I'm here to help you understand. See, what is the number of this term? This is term 1, right? What is the number of this term? 2, right? What is the number of this term? 3. And this 4. And this, let's say, n. Alright, this is nth term. So generally, this is first term, second term, third term, fourth term. We don't know how many numbers. So we are writing the last as nth term. Nth term. Alright. So generally, to find the common difference, what did we discuss? We said that we subtract the first term from second term, or we subtract the second term from third term, or we subtract the third term from fourth term. Let's apply these three. A plus D minus A, this 2 minus 1, which gives me minus A plus A cancel D. Let's find this. A plus 2D minus A plus D. I'm subtracting second term from third term. Alright, second term from third term. So third term minus second term is equal to, I'm removing brackets, A plus 2D minus A minus D. Alright, minus into plus A, minus into plus D minus D. So A cancel, 2D minus D, 2 apples minus 1 apple is 1 apple. So 1D. We got the D, common difference. Let's find this also. A plus 3D, fourth term, here fourth term, minus A plus 2D. What is this? This is third term. I'm opening brackets. A plus 3D minus into plus A is minus A, minus into plus 2D is minus 2D. Minus A plus A cancel. 3 apples minus 2 apples, 3D minus 2D is equal to D. Alright, I guess we found how to find common difference. It is simply by subtracting nth term with its preceding term. Alright, an is nth term. Here it is a2. Let's say n is 2. a2 minus a2 minus 1. a2 minus a1. This is the formula for common difference. You subtract the first term from second term. You subtract the second term from third term. In the same way, you subtract n minus 1th term from nth term. You get it? So writing in a more general form is this: an minus an minus 1. An is the ultimate number, the last number. An minus 1 is the preceding number, the number just before it. Alright? So this is the formula you should remember for common difference. It is an minus 1. Okay, we'll discuss more about common difference, and in this lesson we have successfully understood what is a progression. A progression is a series which has terms and a particular pattern. The definition of progression is that an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding number except the first term. Alright, and we also found the general form of an AP, which is A plus D, A plus 2D, and so on till n terms. And then we also tried deriving how to find common difference. Alright, let's take this up and continue in our next discussion. And for that, your task for your next lesson would be find some arithmetic progressions on your own. Just give random A and D values and write down at least 5 arithmetic progressions on your own. You can also try on numerator denominators, and then you can also try on negative values. Cool. All the best. I'll see you again. Be happy. Keep learning. Bye.
So we come to an end to today's lecture. Thanks a lot for watching this, and stay tuned for the upcoming ones. Don't forget to follow @fastesthumancalculator and @exp.infi on Instagram, and subscribe to our YouTube channel.